So last day we learned how to solve trigonometric equations. Today we're just going to extend that. We did a lot of, well, really exclusively sine and cosine. We learned how to solve it with a ratio and also when it was equal to 1, -1, and 0. So today we're going to just continue on that. We're going to continue on with the tangent curve, double angles, triple angles, and quadratic trigonometric equations. So solve in the given interval. Okay, so the first one we're going to do is determine when the tangent of angle x is equal to -√3, and we're going to do that for all angles that fall between 0 and 4 pi. So solving tangent is just the concept is a little bit different than solving the sine and the cosine, but the process is going to be exactly the same. Okay, and I'll talk about the difference and I'll show it to you in graphical form. Okay, but we can do it the exact same way that we did it on Tuesday. So the first thing you're going to do is to determine the locations of the terminal arms. Because tangent is negative in quadrant 2 and in quadrant 4. So that's your first step, to use the ratio, whether it's positive or negative, determine the proper location of the terminal arms. Your next step is to determine the size of your acute related angle. Where do I get that information from? The size of the red angle I drew on both those diagrams. Okay, right. Okay. So I look at my special triangles and one, √2, and this would be pi over 4. And then my other one, 2, 1, square root of 3. Top guy here is pi over 6, and the bottom guy here is pi over 3. So which angle would give me a tangent ratio of √3 or √3 over 1? Sure? Pi over 3. Good. Okay, so here's pi over 3. The opposite side is √3. The adjacent side is 1, which is √3 over 1, which is √3. So I put my pi over 3 into my related angle spot. Once I've done that, my next step is to figure out the angles in standard position. So these blue angles here, because those are really the answers to my question. So angle x is equal to pi minus pi over 3, which is 2 pi over 3. And angle x is equal to 2 pi minus pi over 3, which is 7 pi over 3. So this, it's a little bit different because remember the sine and the cosine curve, there's two primary angles because the sine and the cosine curve are equal to a value twice in its primary cycle. Okay? The tangent's a little bit different. So if I graph the tangent curve, this is the graph of the tangent curve. Okay? So this right here is the tangent curve. And then it repeats itself forever and ever. Okay? So unlike the sine and the cosine curve, the tangent curve is only going to have one answer, and then that answer repeats itself every pi. Okay? So really, for the tangent curve, when we did this, this is my first answer. Okay? And this answer is really just this answer. If I add pi to it, I get that answer. I just back that. I didn't do that correct. That didn't make sense. That should be, yeah. Say something. Sure. Now I did it correctly. So if I add pi to this answer, I get that answer. Okay. So really with tangent, there's only one primary root, and then the other roots are just multiples of the period. What's the period of tangent? Yep. Pi. Okay, so we're going to add on multiples of pi. I'll write that here. So that's the only difference really for tangent, but you can do the process the exact same way, because if you do it like the sine and the cosine curve, you don't have to change the process. And doing these two angles will give you the two answers you need anyway. So you might as well just continue on the process. Okay? So all these questions are going to be done the exact same way then. Use the negative to determine where the terminal arms are. Use your special triangles to figure out the related angle. And again, if the ratio isn't in your special triangles, you would use your calculator. And then figure out the answer in standard position. Then the last step, then this is often forgotten on the test, look up to the interval and answer the questions inside the interval. Okay? Because these two guys here, there's still more of them, right? How do I get to my other answers? Well, I add on multiples of the period. So if I add on multiples to period to this guy, that would be 8 pi over 3. Add it again, this would be 11 pi over 3. Right, which is still inside my range, because my range goes from 0 to 4 pi, but I can write that as 12 pi over 3. And if I add on another period, I'm going to be outside my interval. So those are my 4 answers. Any questions on that? Okay, process is always going to be the same, even if the angle changes. So this question is asking, when is the sine of 2x equal to negative 1 over 2? Okay, so now we're changing the angle. Okay, now I don't want to figure out angle x. I want to figure out what the sine of 2x would give me negative 1/2. The guide does this question in a different way. It's just a different way. If you choose to do it that way, great. If you choose to do it my way, good for you as well. Okay, whichever way you prefer. But my way is just an extension of what we did here. Okay, so it's the same process. You don't have to remember anything different. So just like before, you look for the positive and the negative. Sine is negative in quadrant 3 and in quadrant 4. You look for what angle would give you a sine ratio of 1/2. So here's my 1, here's my 2. The 1 is the opposite side, so it has to be pi over 6. So pi over 6 is my related angle. Now we're on to step 3, where I find my angle in standard position. So these blue angles here, I need to find the size of those. Okay. And remember that it would be pi plus pi over 6. But that's my angle is equal to that, right? And what's this, bless you, and what's my angle in this question? Not x, but 2x. So I set my angle equal to that. So I get 2x is equal to, finding a common denominator, is 7 pi over 6. Ultimately, I'm trying to solve for x. I don't want the 2 in front of the x. How do I get rid of it? Right. And if I divide a fraction by 2, it's essentially like multiplying the denominator by 2. So that's my first answer. I'm going to do the exact same thing over here. So it's the exact same process that we did before, except now we have a number in front of the x that we have to divide to. And it doesn't matter what number's in front of that x. It could be a 3, it could be a 4, it could be a 7. The processes are going to stay the exact same way. This one here was 2x minus pi over 6. So 2x is equal to 11 pi over 6. And I get 11 pi over 12. Okay. Find the terminal location of the terminal arms, find the related angle, find the angle standard position. Now the next step is to add on what to my answer? To decide the answer. Okay. Multiples of the, what's the period of this function? Because this is the part that changes too. 2 pi is the period of the sine, but remember this 2 changes the period, right? So reaching back to 1011, so this is still on 1011, so those people can jump in here. What's the period of this function now? Yep, pi. Because remember that the period is 2 pi divided by the c value. My c value here is 2. So now I have a new period, which is pi. So I'm still going to add on multiples of periods of the period to my answer, except I have to account for the period that's now changed. Okay? So here, if I add on the period to here, so adding on pi here, or 12 pi over 12 pi, which would be 19 pi over 12, which fits inside of my range, right? Because if I put this over 12, this is from 0 to 24 pi over 12. So any answers less than 24 pi over 12 are going to fit inside my range. But if I add on another pi, I'll be outside of my range, so I'm done with that one. Move over to this guy here, add on a multiple of the period, and I would get 23 pi over 12, which also fits inside my range, but if I add on again, I'd be outside my range. So when is the sine of 2x equal to negative 1/2? According to my answer here, it's equal to 1/2 in 4 different locations. So I'm just going to show you graphically, again, so you can get a better picture of what's happening. So as soon as I plot the sine of 2x, right, I've now got a transformed function. Okay, so here's my sine of 2x, and you can see that here's the sine curve, but it only takes pi to complete itself, right? But I want my answers, when was it equal to negative 1/2? Between 0 and 2 pi. Well, it's equal to negative 1/2 here and here. Those are my 2 primary answers. And then I took this answer and added pi to it to get this answer. And I took this answer, added pi to it to get that answer. And that's why I got my 4 answers. Does that make sense? Okay. So this process can be done for any single number that's in front of this x. So if this was a 3 here, you would do everything the same, except you would divide by 3 here, and you would add on multiples of 2 pi over 3. If it was a 4, you'd add on multiples of 2 pi over 4. You guys know what I mean? The guide does it a little bit different. If you like the way the guide does it, feel free to do it that way. Okay? The beauty part of this way is it's done the exact same way every single time. Okay, now let's get on to trig equation with quadratics. Okay, so I want to know when is 3 times the cosine of x squared plus 7 times the cosine of x plus 2 equal to 0. So this is a quadratic. What makes it a quadratic is the exponent 2. So in order to solve quadratics, what do you always have to do? Back. Okay? So the guide gives you a method for simplifying your factoring if you're confused by the cosine x's. So if you don't like them, what they say is take your trig ratio and set it equal to another letter. Don't use x, because x is the angle. Okay? And if you do that in a test, you're going to lose marks. Okay? So use another letter other than whatever the angle is. And then just everywhere you see a cosine x, replace it with the letter. So I'm doing it in green because some of you won't need to do this. Okay? But then this is more like an equation that you use to factor. Right? So then you factor it. It's a hard type trinomial. So you factor it using your hard type trinomial methods that you've learned, right? But do yourself a favor and just check to make sure that it's correct on your test. Okay? 3a times a is 3a squared. 3a times 2 is 6a. 1 times a is 1a. Add them together, you do get your 7. This times this is 2. Just takes a second to make sure you've done it correctly. Once you've done it correctly, set your two linear factors equal to 0. And then solve for a. But remember, you weren't asked to solve for a. You were asked to solve for what a was equal to, which was cosine of x. So make sure that you substitute back in your cosine of x. If you don't do this, again, you're going to lose some form marks. So really, it boils down to taking a trigonometric equation, which is a quadratic, and then factoring it, and then now you get two equations to solve. And if you can solve the equations that we've done in the past two lessons, then it's really just an extension of that. So let's do the first equation first. So I want to know when the cosine of x is equal to negative 1/3. So write the same process for all equations. Doesn't matter if there's a number there or not. It's the same process. Draw your set of axes. Draw the terminal arms in the proper location. Cosine is negative in quadrant 2. Cosine is negative in quadrant 3. Figure out the size of your related angle. So again, 3 is not a side in my special triangle, so I have to use my calculator. Right? So you grab your calculator, you make sure it's on radians. You take, depending how your calculator works, this one I would do 1 divided by 3, hit equals, shift cosine. And remember, I don't use the negative. The negative tells me where to put the terminal arms. If I do that and round it off to 2 decimal places, I got that as my related angle. So remember, the related angles are not the answer to my question, right? They just help me figure out my answers, which are those answers in standard position. So I figure out this one by taking pi, which we're going to estimate to 3.14, and subtracting off. And then this one here, we take pi and add it to my related angle. So I've got my two primary roots. Once I have my two primary roots, I look up to my interval and make sure that if I need to add on multiples of the period, I do so to fit inside my interval. Do I need to add on anything in this example? No, okay, because it goes from 0 to 2. Okay, so that's your first one. Now you solve this equation. What's the answer to this equation? When is the cosine of x equal to negative 2? Right, never, because the range of the cosine curve goes up to 1 and down to negative 1. Okay? So it'll never be equal to negative 2. Any questions on this? Okay, so they do get a little bit harder when they're written as a mix of different trigonometric functions and different angle sizes. So I'll try to do an example that encompasses both of them. I'd like to figure out when the sine of x plus 3 times the cosine of 2x is equal to 1. And I want my answers between 0 and 2 pi. Okay. Whenever you're solving a quadratic where the ratios are different, okay, and they can't be common factored out, that's important. If you can common factor them out, the question becomes easier. you want to make the ratios into the same ratio, meaning that you want to change this sine into a cosine, or you want to change this cosine into a sine. Also, you have to make sure that the angles are the same. If this is an x, and this is a 2x, you either have to make this 2x so that it just has an x in it, or you want to make this into a 2x, which is pretty hard to do, so you'd always want to use your double angle form. Okay? Because the double angle formula gets rid of this 2 in front of the x. Anybody have a formula sheet in front of them? Okay. So there's 3 for the cosine of 2x, right? Which one do you think you would choose? And tell me why. Keeping in mind you want the angle size to be the same and you want the ratio to be the same. So out of the 3 cosine 2x's, which one do you think you would choose? Which one's the second one? Okay, so if I put in cos x squared minus 1, I'm going to get the x's are going to match up, but then I'm going to have a cosine with a sine. I don't want that. So which one? I want the one that has sine in it, right? So is it the first one? Yes. Again, you're getting a cosine. You don't want a cosine. You want them all to be sine. So by process of elimination, right, exactly. So again, you can choose any one you want, right? But remember that you want the ratios to be the same. So now I have everything in terms of sine, and you want the angle to be the same. And I forgot my cue there. So now my equation only has sine x's in it, okay, which is what we want. What do I do from here? Okay. So multiplying out to 3. Sine x plus 3 minus 6 sine x squared equals 1. What do I do now? Okay. Factor? Right. Okay, remember, whenever you're solving a quadratic, you always have to set it equal to 0. So we're going to do that. So the 1 would come across, become a negative 1, added to the 3, become a positive 2. Okay, so now you're in a position to factor whenever you have your quadratic equal to 0. Personally, I always don't like it when I have a quadratic with the leading one's a negative, so I always change that by multiplying everything by -1. And multiplying everything by -1 essentially just changes the sign of all the terms. And now I don't have to worry about having that negative leading coefficient, which makes it a little bit easier. Okay. So now you would factor the hard type trinomial. Again, in factoring the hard type trinomial is harder than that, right? I just skipped over that part. I've been doing a lot of them since we're going to do it back in grade 10. Just make sure you've done it correctly. This times this is that. This times this is 3 of them. This times that is -4 of them. Add to give me -1 of them. And that times that is -2. So I know I've done it correctly. Now I solve when the sine of x is equal to 2/3 by setting that guy equal to 0. And when the sine of x is equal to -1 by setting the second one equal to 0. So I have 2 equations to solve. And we know how to solve these guys. Equation number 1. Determine where the sine ratio is positive. Sine ratio is positive in quadrant 1 and in quadrant 2. Determine your related angle. Again, there's that 3 again, which isn't a side in our special triangle, so we have to use our calculator once again. 2 divided by 3, hit equals, second sine, and I got 0.729, which I'll round off to 0.73. those are my related angles. I need to figure out my angle in standard position, the blue one here and this blue one. Well, the blue one is the same as the related angle because it's in the first quadrant. And the blue guy here is pi, which I'll approximate to 3.14, subtracting off. And I get that approximate value of 2.41. Again, look at the interval. The interval is from 0 to 2 pi, so I don't have to add on anything else to get those answers. So those are my first two answers. My second answers come from my second equation when the sine of x is equal to -1/2. Sine is negative in quadrant 3 and in quadrant 4. 1 and 2 are sides in my special triangles. So we go back to our special triangles. Sine is the opposite side over the hypotenuse, so that'll be pi over 6. Determine your angle in standard position. Pi plus pi over 6. This time I can use the exact value for pi because I have the exact value for the related angle, which is 7 pi over 6. And this guy here is 2 pi minus pi over 6, which is 11 pi over 6. So for all trigonometric equations, again, the process is the same. You look at the ratio, draw the terminal arms, figure out the related angle, figure out the angle in standard position, get your two answers, and look to see if you need to add on multiples of the period to fit inside of your interval range. If your period changes because there's a number in front of it, like in this example, then account for it. By doing this method or the method in the back. So any questions? Okay, so you have enough information now to be successful in the 1213. So remember that there is the 1213 quiz in D2L, and remember that the answers aren't in the quiz part, well, the multiple choice answers are, but the written out full solution answers are posted in D2L as well. Okay?